Okay, here we are back with lecture 4.3 for chapter 4, and we're going to distinguish among our atoms on the periodic table and to explain how to do that. First we have the atomic number. The atomic number of an element equals the number of protons in the element, but it also represents the number of electrons in a neutral atom. Okay. However, it's only in a neutral atom, and because the number of electrons differ from protons and ions, that we don't actually call that the atomic number is equal to the number of electrons. Okay, in fact, each element is different because they have different atomic numbers or different numbers of protons. All atoms of the same element have the same number of protons, and the atomic number on the periodic table is the whole number you will find in any one particular box. Okay. Now, the number of protons equals the number of electrons in neutral atoms, which produces an electrical balance, and that's why atoms are considered electrically neutral, because you have the same number of protons and electrons. So protons are the things in atoms that don't change. The atomic number, no change in protons, because if you change the protons, it would change the element itself, and so we don't really consider that changing within an atom. However, the mass number is a little different. Each individual atom has a certain number of protons and neutrons in the nucleus. These protons and neutrons in the nucleus are called nucleons. The combined total of nucleons in an individual atom is called the mass number. And so if you have protons and neutrons added together to give you the mass number, okay, and then you have just the protons, which equal the atomic number, then if you subtract the atomic number from the mass number, you will be left with the number of neutrons. And it is just because we can have different numbers of neutrons in the nucleus, but still be within the same element. These are called isotopes. Which takes us to the next page. Isotopes are just versions of the same element with varying numbers of neutrons or different mass numbers. Okay, and the most famous pairing might be carbon-12 and carbon-14, where carbon could have a mass number of 12, which would be 6 protons and 6 neutrons. Or there's carbon-14, which would be 6 protons still, because it's still carbon, so it's going to have the same protons. But this one would have 8 neutrons. And so they're both carbon, but they're isotopes of the same element, just with differing mass numbers. Now, the way we write this, and we've sort of hinted at it with these two things up here, is in isotopic notation. And we write these with 3 numbers. There's A, Z, and X. A, Z, and X, where A represents the mass number, okay, which is the number of protons plus neutrons. X is the chemical symbol, and Z is the atomic number which is the number of protons. So let's try this with these examples down here. When a magnesium atom has a mass of 23, an atomic number of 12, it's going to have 12 protons, 11 neutrons, and 12 electrons. So what are we going to have? Well, the mass number is 23, so the 23 is going to go up top. It is magnesium. Magnesium has the chemical symbol Mg, and then it also has 12 protons. And this is the isotopic notation for magnesium 23. Okay, this brings us to the atomic mass of an atom. And the atomic mass of an atom is measured in atomic mass units. I actually want you guys to cross this part out. Don't worry about the total mass of an atom. Okay, atomic mass is measured in atomic mass units. Okay, carbon-12, like we referred to up above, carbon-12 is the reference standard for determining the mass of all atoms. In fact, B right here is the standard. It is an official California standard that you guys need to know, because it's foundational for the atomic mass. Now, that a carbon-12 atom has a mass of 12 AMU, and that 1 AMU is defined as 1/12 of the mass of a carbon-12 atom. Okay, protons and neutrons have mass of about 1 AMU, where electrons are about 0 AMU. Protons and neutrons are slightly less than 1 atomic mass unit, and electrons are slightly more than 0 atomic mass units. The atomic mass of each element is the weighted average mass number of the element, and it reflects the relative abundance in nature. So for example, chlorine has 2 isotopes. It is 75.5% of the chlorine is chlorine 35, and 24.47% is chlorine 37. So the way we get the actual atomic mass of 35.45 is we take these numbers and we calculate the weighted average. So this is going to be 0.7553 times 34.969 for the AMUs for the CL35, and then we're going to add that to 0.2447 times 36,966 for the mass of the chlorine 37. But these numbers over here, these fractions, add up to 1, and so the total mass we're going to get is going to be equal to 100% of the average mass. And this winds up being 35.45, which is pretty much what we were expecting over here. Okay, and I just did this over here for room. You want to put all this information. That's where it goes in the notes. Okay, and the atomic mass is the secondary number found with each element on most periodic tables. So here's a look at a periodic table. And these whole numbers are the atomic numbers, and these with decimals between them, those are the atomic masses. And this brings us to if we change, and that was if we change our neutrons, was the previous page. This page is now if we change our number of electrons. If we change electrons, we are creating ions. Ions are charged atoms with an imbalance in the proton-electron ratio. Okay, the charge on the ion is determined by the number of protons minus the number of electrons. Positively charged ions are called cations. Notice the T resembles a plus. That's how we remember that these cations are positive. And they have a lack of electrons. They have fewer electrons than protons. Negatively charged ions are called anions, and they have a surplus of electrons. So aluminum with 13 protons and 10 electrons, as compared to its neutral atom, this aluminum has lost 3 electrons. Okay, because if it was a neutral atom, it would have 13 protons and 13 electrons. This one only has 10, so it's lost 3 electrons, giving it a positive charge. Oxygen normally has 8 protons and 8 electrons, but its ion has 10 electrons. That gives it therefore it becomes O2, and oxygen has then gained 2 electrons. So here are a couple of examples for you to try. The first one is nitrogen. Nitrogen 15. I want you to find the number of protons, neutrons, and electrons. And do the same thing for iron, which will be... Oh, I'm sorry. And this is A3 minus, and this is A2 plus, and tell me how many protons, neutrons, and electrons. So you should pause here and try and figure this out for yourself, and then come back to this when you think you have an answer. Okay. Hopefully you've attempted this on your own, and the answers would be the following. There you have it. You would have 7 protons for this nitrogen atom. That's what makes it nitrogen. 8 neutrons, because the 7 plus the 8 makes the 15. And then 10 electrons, because this -3 charge means that this nitrogen has gained 3 electrons over this 7 to create 10. Down here, iron, it's iron, so it has 26 protons. But because its mass number is 56, it's going to have 30 neutrons. However, it's lost 2 electrons, and that gives it a positive 2 charge, so it'll be 24 electrons. That will do it for section 4.3 lecture. We have a lab on block day, and to illustrate atomic mass. And so this is it for the lecture for chapter 4. So this is B-Dog signing out.